Okay, seems like we're live.
Right. Welcome, everyone. Thank you for joining today. My name is Lisa James, and I'm happy to be your moderator. We have some great content to share with you, and we're excited to get started. But a couple of housekeeping things. We will be using chat to share comments and questions, and we will address the questions at the end of the presentation. So if there is something that we don't think we can answer adequately on the call, we will note it and reach out offline, but we will try to get through as many questions as we can. So definitely engage using chat. On the rare occurrence that we lose connection with our speaker, we just ask for your patience as we take a couple minutes to reconnect. Also, at the end of the presentation, we will be sharing the recording, so you will have it to view on demand. Okay, and without further ado, I'm happy to pass it on to our speaker, Tim Mamo. Tim, take it away.
Cool. Thanks, Lisa. Hello, everyone. Feel free to put in the chat where you're coming from, say hello, shout out. Hi, Ahmed. Cool to see you. Again, really fun to be here and looking forward to all the questions. But first, I'll answer the most important question, the poster. That is not a poster, actually. It's a 1,000-piece puzzle, which took forever to build. Because I always get asked the question. But yeah, cool. So, as Lisa noted, I'm Tim Mamo. I am a senior developer advocate here at DigitalOcean. I do a plethora of things, one of them being webinars like this. I interact with the community, really enjoy talking to people, figuring out what their issues are, and trying to help them out as much as possible. I am in the Netherlands, so hopefully you're seeing me nice and clear, but do shout if there's anything within the live stream that doesn't go right. So without further ado, I'll talk to you today about discovering the power of multi-data center cloud deployment and why you'd want to do that. So to start off, let's discuss why would you want to do multi-data cloud deployment? Because it's not easy. Let's get this out of the way. It is not an easy task to do multi-data center deployments, but it is extremely useful. And the first thing is obviously talking about regulatory compliance. Obviously, there are laws and regulations that might govern data collection. So here in Europe, we've got GDPR. In Australia, I know that there is the Privacy Act of 1988. And you need to adhere to those regulations to make sure that you can continue to do your business and serve your customers. And often these regulatory compliances most of the times prohibit where you can store your data, and it's usually cannot store them outside of national boundaries. So within Europe, you need to store data within Europe, similarly in Australia. So using data centers that have in different geographies can be quite important for companies, especially companies that are within, for example, the finance sector or the medical sector, to comply with regulatory laws. The other thing of why you'd want to do multi-data center cloud deployment is to recover quickly from your failures. I don't think 100% availability is ever possible. That's a dream which we keep on chasing. Try and get to as close to as possible. But you need to prepare for the worst. And failures can occur. So outages, natural disasters, we're getting more and more issues within the environment resulting from fires, as we've seen recently. And you want to make sure that you can recover fairly quickly for your customers. Make sure that data is not lost and is retained. So businesses need to protect themselves and their customers from any of these situations. And even though businesses do backups, and hopefully we all do backups, restoring those backups can be time consuming at times. So you want to have a way where you can quickly switch on another data center and reroute your traffic to that data center while you investigate what's happening, why the failure is occurring, and while you do your backup and bring everything up and running again. So for any reason that the data center goes off, you can reroute traffic fairly quickly and then do your analysis in a more calmly manner, knowing that your customers are still being served. And finally, the other reason you do want to definitely deploy in a multi-data center cloud environment is to optimize your workloads. And you want to scale your resources geographically. So one way of doing one reason is to optimize on structured data like media files, photos, text files that use object storage and that can be stored in CDNs. So when you have your data distributed across multiple data centers, that data can be deployed to CDNs a lot more efficiently. If a user uploads a static file to a certain point within a data center, that can be networked and deployed all over geographically, all over wherever you serve your customers a lot more efficiently, hence reducing the wait time for your customers and speeding up the download processes. Another way of optimization is your read-write operations for structured data. So talk about databases, so on and so forth. If you have a centralized application that is distributed across various edge nodes, you can write to one central master database, and that makes it a lot more fast. And then have that database scaled in read-only geographically distributed data centers. So the latency to write would still be the same, but then to read might be a lot faster. You might also want to decide to have databases distributed geographically as well, again, maybe to comply with regulatory laws, and also to make it even more efficient for your end customer. So once you've decided that you actually do need to create a multi-data center cloud deployment, you want to understand how to choose the correct data center, what locations you need. So you need to consider the geographic location of your end user. Sorry. So you want to pick a geographic location that is as close as possible to your most frequent users. This obviously will then improve the latency for your end user. And the latency number, even though sometimes might not seem important because we're talking milliseconds most of the times, the constant back and forth communication between your application and your user can increase that wait time. And that latency also can improve on your SEO. So using tools like Google Analytics, for example, you can segment traffic by geography and understand how your application is being used. And once you start identifying those locations where your users are, you can optimally deploy your application to different geographies. So understand where the high traffic locations are and spin up those locations in those different regions. Another thing to factor in is the network infrastructure and connectivity. So this is important to consider because for high traffic volumes like live streaming, audio, video conferencing, VoIP, gaming applications, you want to make sure that the network infrastructure is robust and secure, and that the quality of service provided to the customers is consistent. So you want to ensure that the data centers you are using some of the best network infrastructure out there. And apart from the network infrastructure, there's also the high performance of the hardware. So when you choose a data center, you want to ensure that the data center is using some of the latest and greatest in compute, storage, again, networking, and so on and so forth to host your application. For example, when looking at storage, having NVMe So the latest standard for storage, ensuring you've got exceptional performance in IOPS, throughput, so on and so forth, will make sure that you're less prone to failure, but also because you don't have electromechanical parts moving for an NVMe, but also, again, reducing that latency your application uses to compute and then send the data back to the user. So transactional databases, definitely you want to ensure that you're using stuff like NVMe to make the application a lot more faster. And finally, prioritize a data center that offers a complete solution as much as possible. You don't want to be distributing parts of your application in different data centers. You want to have a data center that encompasses everything in one. It's easier to manage, and a lot easier to monitor. And that gets me to our most recent database, the one in Sydney, in Australia. So we recently opened our Sydney data center a few months ago, and this has been built from the ground up. It's got excellent network connectivity and performance improvements. So we've seen about a 6-time reduction in data round trip for customers who were previously using our DigitalOcean Singapore center and then moved to Sydney data centers. And we've managed to do this because we're using global communication services. We've put in a network which is extremely resilient and redundant. We've got connectivities approaching up to 1 to 1 terabits per second, and there's single hop access from Sydney to Perth. Also, our connections to California and Singapore are extremely low. The latency is extremely low because our end-to-end physical path is direct. So you can ensure yourself that the latency we've been talking about is reduced a lot more, and there is good throughput for your customers. About 75% of the residents in Australia will ensure that there is one single hop from our Sydney data center. We've also got a network design that can help you scale. So as I said, we've built this data center from the ground up, and we've built it in a modular way rather than our monolithic way of doing things. It helps us allow to separate devices like core, routes, and switches. So when we want to do any maintenance, any hardware malfunction that can happen, this will minimize any issues on your side. We can analyze what's going on or do our maintenance without impacting you at all. The modular choice, in essence, increases overall resilience. It's got the latest generation 400 gig Ethernet-enabled routers. And again, it ensures that your business can quickly grow and scale. If you get that spike in traffic, you can rest assured that that traffic can go through easily. And we ensured that the Sydney data center will offer a complete solution. It's a one-stop shop for, droplets, Kubernetes clusters, volume storage, spaces, managed databases, and more. So you don't need to focus on other data centers. You get everything in that one data center DigitalOcean offers. We've also ensured that the reliability and privacy is paramount. We have 54 megawatt backup systems, UPS backup systems, as well as generators, which will kick in if anything happens. All the equipment is deployed in a secure cage with floor-to-ceiling panels, and it's got several layers of physical and biometric security procedures. If I go to Sydney and show them that I work for DigitalOcean, even I wouldn't be able to get into the data center. Only specific people are allowed to get in. So you know that the data center is secure. And you can ensure that we try to minimize human error as much as possible. And finally, pricing is the pricing simplicity at DigitalOcean is at its core. The philosophy at DigitalOcean is that you get a flat pricing across all data centers. So even once you start deploying to multiple data centers, you don't need to get out the big calculators and try to figure out what anything's going to cost you. It's a one-stop shop, one price, no matter what the data center is. So you can get this affordable pricing with industry-leading bandwidth pricing across all data centers within DigitalOcean, even at our newest data center in Sydney. And you also don't need to guess whether all this bandwidth is going to cost you. Our cost for bandwidth and networking is extremely low compared to other data centers. So all of that, I do have a demo prepared, and this demo will deploy. I've deployed 2 clusters. So the demo is a multi-cluster, multi-region setup with Linkerd. The QR code takes you to a blog post which shows you what to do and how to do it. But in essence, I've got 2 clusters, one deployed in Sydney and another deployed in San Francisco in our data centers, DigitalOcean data centers. And what I'll be doing is I'll show you how you can network the traffic between the 2 data centers seamlessly for the 2 clusters by setting up a mirrored service. In essence, what I'll deploy is I'll deploy a application within Sydney, and then I'll have a mirrored service that points to a gateway in Sydney, and all the traffic coming through Sydney will then go through coming through San Francisco will then go to Sydney to analyze the data. So as I said, I've got 2 clusters already up and running. Nothing else. Fairly standard clusters. One in east, as I said, in Sydney, and the other one in west in San Francisco. Nothing more. I just spun them up to save time. And what I've also done is I've created certificates that I will also use to ensure security and encryption between the communication between the 2 data centers. So the first thing to do is install Linkerd and its CRDs onto both clusters. So Linkerd is an extremely efficient service mesh. It uses minimal resources on your Kubernetes clusters and is a CNCF approved project. I'll then configure Linkerd on both clusters. And again, all these commands, which I'm copy pasting, you will get from the blog post. I'll show you the QR code again. And once Linkerd is deployed and configured on both clusters, we want to ensure that the 2 clusters can talk to each other. And we do this by installing multi-cluster, which is also, again, provided by Linkerd. They also have ways of splitting traffic between the 2 clusters, which, again, I'm not going to show today, but there is ways to do that. And also failovers, where you can set traffic to go to another cluster if one of your clusters goes down or anything within that application goes down. So you can have a blue-green deployment or canary deployment system within your environment. So once that is done, as I said, I'll be deploying multi-cluster components and also visualization from Linkerd. Again, control plane for Kubernetes is setting it up. As I said, the two clusters fairly far apart, but are connected with the lowest latency, with the lowest networking latency as possible from San Francisco to Sydney. It is fairly early in the morning here for me, so I know for you guys it's around 4 o'clock, which is great. Okay. Control plane came live, and then deploying the gateway. So this is the gateway which will allow the communication between the clusters. And finally, I'll install some visualization so that we can see the traffic going on. So as that is being done, I'll explain exactly what's going on. I've now installed the gateway and service mirror and gateway in both clusters. So this service mirror will know how to connect to the other cluster. Once that is done, I'll deploy an application, and this is emoji voting application, which is provided by Linkerd again, which has a bot that's automatically votes for the emojis, and I'll be deleting the bot in the cluster in the East region. And then once that is done, we'll see the traffic going from the West to the East cluster. So still installing a few visualization setup. And as I said, we can also set traffic splitting if we want, or failure mechanisms to ensure that traffic keeps on flowing. So I'm now going to deploy the emoji vote service, and I'll be removing the unnecessary deployments in the West region and also the voting bot in the East region. So I'll be removing these three components from the West region and the voting bot from the East region. And I'm doing this so that we can see the traffic. When we see traffic going on, we definitely know it's coming from the West region. Okay. So we've installed the application in the West region, and now it's deploying the application in the East region. All of this is done automatically through the scripts provided by Linkerd. Now, once that is done, I'll create the mirror. I'm just basically labeling the service that we want to mirror from East to West, and therefore creating this web service East. And we can see that in the West, oh, I didn't put in, I didn't set the context. So if I check my namespace and like that, a kubectl service. Yeah. And if I do a context for east, oh, I need to change the namespace. That's deployed correctly. I'll just redeploy in my west region. Demo gods are not being kind to me. I promise you this worked. Yeah, this is unchanged. So if I do a context switch and I check my deployments, yeah, and if I get my services, oh, this is my west. I want to be in my east. And change context. Ah. Now if I do that. Okay. So the demo codes are not working for me today. I might have missed a command which I'm not seeing. Let me make sure I have everything. I installed the multi-cluster, I installed the certificates, I installed Linkerd. Did I miss out on this command? Well, I didn't link. Well, I installed multi-clusters, but I didn't link the clusters. Yep, there you go. So this should now work. If I mirror okay, there you go. Missed out on a command. Read the manual. So we've got everything up and running. I'll delete the unnecessary services and deployment. And I'll now show you that. Where are we? Oh. So we've got the endpoint for the web services east in the west cluster having that IP address, and I'll show you that the gateway in the east cluster should have the same IP address. In fact, it is. So they can now communicate with each other. Once that is done, I'll set the bot to understand where it needs to send the information. And then we can see on the dashboard, the demo god help me out. Yeah. So here you go, services, web service east. We can see the traffic is flowing from the vote bot to web services east, and then within the West cluster. And again, the demo gods are not happy with me today. So the deployment bot is serving traffic to the service east, which would then send traffic to the east cluster. Again, I do apologize for the demos not fully working, but you can try it out yourself if you scan the QR code. I know there is a question with regards to load balancers. So when you deploy the gateway, I can show you. I believe my Linkerd multi-cluster. It automatically deploys the load balancer for you. So you do need a load balancer so that the traffic can go through. And you have mutual CLS between the two clusters. On that note, I'll answer questions. But do scan, as I said, that QR code and test it out for yourself. It does work, I promise you. But obviously, it being fairly early in the morning here, things don't go as planned. On that note, if you have any questions, more than happy to go over that.
All right, let's check out the chat. We have a question, Tim. How many server accounts can be verified within one debit card?
I'm not sure what you mean by server accounts, but once you open a DigitalOcean account, you can deploy to any region within the DigitalOcean sphere. So as I've shown you, I've deployed onto San Francisco and Sydney. I had 3 nodes, so 3 droplets in Sydney and 3 droplets in San Francisco. I also have another 10 droplets in Amsterdam. So you can deploy a fair amount of servers in any geographical location within our data centers. If you do reach a limit, I think there is a soft limit of, I believe it's 250, but that's a quick request to support. And within a few minutes, that request can be increased fairly easily.
Okay, awesome. And Tabrez, if that didn't answer your question, you can if you can put some clarification into the chat, that would be helpful. Another question we had, just wondering if you can provide 2 network connections to IP addresses to your servers, i.e. not just the best connection, but also the second best connection.
2 network connections. So am I correct to assume, so when people say servers, I'm going to assume droplets and IP addresses. If it's a public IP address, you can only attach 1 public IP address to a droplet. You cannot have 2 public IP addresses. It's like saying having 2 addresses for your house. Not really useful. Not that doable. So you cannot have 2 IP addresses connected to one server. 2 public IP addresses connected to one server.
Okay.
You can point 1 IP address to a load balancer and then have that load balancer have an IP address. So there are networking ways to get multiple IP addresses that point in the same direction, but that is rerouting.
All right. We have a question from Jacob. What's the average latency from Singapore to Sydney?
I don't have the actual numbers, I'm afraid, off the top of my head. But had you seen had the demo gods been kind to me today, I would have shown you that the latency between, I know that the traffic from San Francisco, for example, to Sydney, when I tested it out, it was in the region of something like 40 milliseconds. So you could see the network traffic, and we'd get the latency from San Francisco to Sydney by tens of milliseconds. So I'd expect Singapore to Sydney to be even shorter.
I think this was a question on the demo. Is that gateway IP provided by DigitalOcean?
So what happens is when you run the script, when you run the shell commands, that shell command deploys deployments, services, rerouting, networking information, so on and so forth. And part of that is a service, which is a load balancer. And when you deploy a load balancer on your Kubernetes cluster, you automatically get, when you deploy a service that is the kind of load balancer, which is the gateway IP you're talking about, DigitalOcean will automatically spin up a load balancer for you. So that is automatically provided.
Okay. And this next question from Mark, I think we answered this. From one server, can you connect to two ISPs? Right.
So you can connect, when you say two servers to one server to two ISPs. I'd like to understand that a little bit more. Maybe you can get me. Feel free to reach out either on LinkedIn, Twitter, not that much nowadays. But Mark, if you reach out to me on LinkedIn, more than happy to discuss that with you. By what do you mean exactly from one server to two ISPs?
Right.
Yep.
What IP do I need to map on my domain? See if I understand this question. My domain DNS a record.
So the DNS a record, you'll have to deploy. So the load balancer deployed in the example, that is only used for connection between the two clusters, for secure connection between the two clusters. If you want to link a domain to your clusters, you'd have to deploy an ingress controller, something similar to Nginx, and then link that A record to the IP address of the ingress controller. So the load balancer created for that ingress controller. And again, the docs for DigitalOcean, which are world-renowned, has all this information. If you do a quick Google search, the docs will explain all of this in detail, step by step.
The last question currently in chat, is there any pricing involved in gateway IP?
So yes, anytime you deploy a load balancer, there will be specific pricing for that. Again, don't know the exact pricing off the top of my head, but when you do deploy a load balancer, there is added pricing for it.
All right, and that was the last question I see on chat. Again, if you have any additional questions or maybe you just want to add further clarification to the question you asked, please feel free to reach out. We have a QR code here. When you registered for this event in your email, you should have also received some additional resources to check out. But if you're interested in learning more, a member of our sales team would be happy to speak to you. So you can fill out the form on the QR code for more immediate follow-up, but just being a registrant to this webcast will make sure someone from our team reaches out if you have any further questions. But thank you, everyone, again for joining. And thank you especially for Tim for leading the conversation today. But we hope you all have a great rest of your day.
Have a good one.